In today's video, we're going to dive in and discuss the continuity of this function. So for us to discuss the continuity of a particular function, and this function is a vector variable function. We're given I, and this part was our j. So the first thing is first, let's rewrite it. So ft is equals to 2 over t to the power negative half I plus open bracket 1 minus exponent negative t over exponent negative t squared sec t. From here, notice how I'm going to rewrite this. I'll say minus, I'll just take here when t is not equal to 0, because the condition is when t is equal to 0, this whole thing is what? It's 0. But when t is not equal to 0, we are having t sine 1 over t, like this, j. Now, for us to discuss the continuity of a function, for a function to be continuous, we must prove these conditions right. The limit of t, the baby function, as it approaches 0, for f of t must be equal to, when we just substitute 0 for t directly. So this condition must be equal to this. So we are going to start by proving the first condition, which is f of 0. So what we are going to do is, wherever there is t, we are just going to replace it with 0. So 2 over t to the power negative half, this can be rewritten as 2 multiplied by t to the power half, because the power is negative. When it goes on top, it will become what? Positive. So now let's substitute 0 for everything. So 2, 0, where there is t, ti. So this is I plus, when I substitute 1, I'll put 0 here, I'll put 0 here, I'll put 0 here as well, minus, when there is 0, there is sine 1 over 0, j. Now, for the first part, you can see that this whole term will be just 0i plus. Now, look for this. For this, exponent 0, this is any number raised to the power 0 is 1. So it will be 1 minus 1, which will be 0 on top. Now, our main interest is on the bottom part. This, we know that it's 1, but what about this? We know that sec x is the same as 1 over cos x. Now, this is the same as 1 over cos 0. Now, what is cos 0? Cos 0 is 1. So it is 1 divided by 1. So it is 1. So it is 0 divided by 1, which is just 0. We subtract. Now, for this one, where you can just see it from, is there. They are saying that when t is equal to 0, this function is what? Is 0. So we know that this also is 0. So this is what we are having here is just 0. So now we have proved for f of 0. Now we have to find as the limit as t approaches 0 for f of t. If we are going to find the same answer, then we should know that this function is continuous. So we apply the limit. The limit as t approaches 0 for f of t. We have 2, let me rewrite it into this way, t half I plus open bracket 1 minus exponent, like this, like this, like this. We're just rewriting everything just rewriting everything the way it is. Now from here we are seeing that we are letting the limit as t approaches 0 for this part and for this part. For the first part, we can just observe as t approaches 0, this term will be 0 because when we substitute 0 here, we are going to have 0i. So let's come to the second part. When t is approaching 0 for this, the limit as t approaches 0, we can see that this whole term will be 0 as well. We put 0 for t, 0, 0, it's just the same for that. So here we are going to have what? We're going to have 0. Now the interesting part comes here. As the limit as t approaches 0 for this function, is it going to be 0 or is it going to be infinite? We have to ask ourselves that question, because see, 1 over t, when you substitute, when t is approaching 0 for this limit, we know that it is going to be what? Infinite. So to prove this, it would be very hard if we just want to use the limit way. So we have to apply another thing for us to solve this. We have to apply, which is the squeeze theorem. So we are going to take this function which we want, which is sine 1 over t. We want to see if it is 0 or if it is infinite. So this function, it is going to be greater than or equal to -1, but it is going to be less than or equal to 1. Now let's look at our function. We have sine 1 over t multiplied by t. So we are going to multiply this whole function with what? With t. We're going to multiply this with t, and the same. So this will be negative t, like this. T multiplied by sine 1 over t. This will be t. Now we just have to ask ourselves one question. We have to apply the limit as t approaches 0 for this side, for the middle part, and the right side. So whatever the answer we are going to get for this, and this, and this, it will be the same. So as t approaches 0 for the left side, it is 0. For this, we don't know. For the right side, it is what? It is 0. So it means even for the middle part, it is what? It is 0. So by using squeeze theorem, we have proved that even the middle part approaches what? Approaches 0, as t is approaching what? Is approaching 0. So this is for our j. So this is 0 as well. Since now we have proved that the limit as t approaches 0 for f of t is equivalent, it's equal to, when we just substitute 0 for t, this function is continuous. Thank you for watching, and if you haven't yet hit that subscribe button, please, you can do as wise so that you don't miss out on future endeavors. Bye bye.